Paper of the day is Main Memory Hash Joints on Multi-Core CPUs, Tuning to the Underlying Hardware. It's a 2013 paper. This paper demonstrates through experimental analysis of different algorithms and architectures that hardware still matters. Joint algorithms that are hardware conscious perform better than the hardware oblivious approaches. The analysis and comparisons in this paper show that many of the claims regarding the behavior of joint algorithms that have appeared in literature are due to selection effects and are not supported by experiments run under different parameter settings. Through the analysis, they shed light on how modern hardware affects the implementation of data operators and provide the fastest implementation of radix joint to date, reaching close to 200 million tuples per second. They use machine and workload configurations that mimic scenarios where in-memory joint processing is most relevant. In particular, all systems where the component truly matters assume a column-oriented storage model. They deliberately choose very narrow tuple configurations where key and payload are 4 and 8 bytes wide. As a side effect, narrow tuples better pronounce the effects that they are interested in, since they put more pressure on systems caching system. Let's look at the contributions of the paper. The first contribution of the paper is algorithmic. They analyze the algorithms proposed in the literature and propose several important optimizations leading to the new algorithms that are more efficient and robust to parameter changes. In doing so, they provide important insights on the effects of multi-core hardware on algorithm design. The second contribution is to put existing claims into context, showing that choice of parameters or hardware features cause the observed behaviors. These results shed light on what parameters play a role in multi-core systems, thereby establishing the basis for the choices a query optimizer for multi-core will need to make. The third and final contribution is to settle the issue of whether tuning to the underlying hardware plays a role. The answer is a definitive yes, as it is only on a narrow combination of parameters and certain architectures where hardware oblivious approaches have an advantage. Let's talk about PS score. Overall, this paper is a decent read, so it gets 7 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. It's a description and measurement of a research prototype. The description of their approach is overall okay, so that makes it 7 out of 10. Its industry value and learning meter is okay, so it gets 7 out of 10 on each. Overall PS score is 7 out of 10, which is okay.